A researcher wishes to conduct a study of the color preference of new car buyers. So suppose that 40% of this population prefer the color blue. If 14 buyers are randomly selected, what is the probability that exactly 8 buyers will prefer blue? I know it's a mouthful for this thing. Here's the deal. Now is the time to introduce you to a specific type of discrete probability. It's called binomial probability distribution. So what is this thing? For binomial probability distribution is a very specific type of distribution. So kind of like the one we see up in here, but it's a very special type of distribution. And you have to meet 3 different criterion before you can use it. What are those 3? First, you have to have a series of true or false. Right? We call that the belong probability. It doesn't matter what the name is. A series of, or I should say this, success or failure. Success or failure experiment. What does that mean? You have to have a probability whether or not the experiment should be designed, whether or not you either gonna have this probability, either this event is either true or not true. So what does that mean? Like, if I say you will pass this class, right? Passing this class or passing this test is either you pass or you don't pass, right? You either pass the class or you do not pass the class. Then there's no third option out of this thing. So what are some examples that's not? Well, if you have, let's say, tomorrow is going to be, let me see, tomorrow is going to be either Monday, Tuesday, Wednesday, Thursday, or Friday, right? Well, there are 5 different options, so that doesn't work. So your experiment cannot be like, remember all the poker games or the poker question that we have? You draw a card. What's the probability that you will get either a queen or the queen or king or whatever? So there are too many choices. You want one. It's true or not true, either success or failure, right? So we call these experiments trials. Right, so that's what they call trials. So you want a series of trials. Just think about, what if you have 10 students and you want to know whether or not they pass the class or not. So you got 10 students, whether or not they pass or fail, and that is 10 of the same experiments, 10 of the same trial that take place at the same time, right? B. What's the second criterion? The criterion would be all the trials must be individually distributed. Well, you know what? Let's just make it easy. It must be independent from one another. So every single trial, right? You have to have each separate trial have to be completely independent, meaning their outcome cannot influence one another. So for example, right, when I say 10 students either pass a class or not, right, unless circumstances is unique, I can assume that one student passing a class doesn't have much to do with another student passing the class. Unless they're working together, of course, then you have some elbow room in this, right? Or here's another example, a better example. Let's say I go and buy a calculator. What are the chances, right, that one is going to be, say, not working, If you buy a calculator from Amazon or something like that, right? Some used calculator, either it works or it doesn't work. Okay, if you buy 10 of them from different buyers, all right, from different buyers, you might have 10 that you will have 10 different trials. You might have 5 not working, 6 not working, or maybe 1 not working. But one calculator not working doesn't mean the other one's not going to work. They are independent. So you got to make sure all the trials must be independent. C. Each trial should have a probability of success. Should have, well, you know what? Each trial should have the same probability of success. So what does that mean? If I say I flip a coin, all right, I can flip the coin 10, 15, 20 times. Each time I flip the coin, the probability are the same, right? It's 50-50 to get a head, right? 50-50 to get a tail. And each time I flip it is independent from another, right? The first flip doesn't have anything to do with the second one. So that would be an example of binomial. So as long as you meet all 3 credentials, then this is what we call a binomial distribution. And then you can use a calculator to get the answer. So, then you look at this guy, well, is this a binomial? Well, here's the thing. Here's what I usually do. I will look at the problem. It says the researcher conducted a study. You have a new car buyer. You have 14 car buyers. So you have a total number of 14 buyers. What does that mean? That means the n equals 14. You have the total number of 14 buyers. So that means you have 14 specific trials that you're doing. Right? Each buyer is a trial in our case. Well, what are we talking about? Suppose that 40% of this population prefer blue. So 40% of them prefers blue. That means the P equals 0.4. The success rate equals 4. So in our case here, if a customer wants a color blue, that's considered a success. If they don't want blue, then it's a failure. Right? So say we're not choosing 2 different colors, we just strictly talk about blue. So P equals 0.4. So what's the next question? The next question is, what is the probability that exactly 8 buyers prefer blue? 8 buyers prefer blue. Well, that means, let me actually move this a little bit. There you go. So what does that mean? That means I want my X equals 8. X is the, you can think about it this way. X is the trial that I want to be successful. Right. So I should maybe write down here just kind of like the legend. Right, or what they mean. N is, so total number of trials is N equals 14. The success rate, right? Success rate or the probability, P equals 0.8, 80%. And we want probability, maybe I should just say probability of 8 successes, like that. So X equals 8, right? So this might be a little bit easier to understand, to translate that into like a general statement, right? So now that we got this information, how do we get the answer? This is what I usually want to write. This is a binomial distribution. Binomial probability, you can say that, is always B, INOM. That's usually the way I call a binomial. That usually for coding, BINOMPDF, and I know it's a little bit crazy, right? BINOMPDF is basically the probability, so the binomial probability of exactly X successes is always binomial PDF, right? And I'll explain the difference. PDF is exactly that point, right? And I will show you the other one later. And it's always could be NPX. I just remember it's like NPR, right? National Broadcast Radio, but it's NPX. So in our case, it's binomial PDF, N is 14, P is 0.8, X is 8, like this. So of course, in all this doesn't mean anything right now until you put in the calculator. So how do we get to the calculator? Here, you have to first press second. So I should, I'm going right now. Second, and then variable, like that. Second, variables, and then you just got slow. You gotta scroll down. Don't click on these guys. Go down all the way until you see binomial PDF. Like that, right? So enter. Now you can type in the numbers. You can type in 14, 0.8, 8. Like that. And then, what should I do? I mess up a little bit here. 14, 0.8. Let me delete this right here. 0.8. And then, I don't know where the 0 come from. And then close parenthesis. Just like that. So let me type this in. 14, right, 0.8, and then 8 equals 0.03224467. Of course, you know you're going to round this up to the 4 decimal place, so there'll be 0.0322. That's 4 decimal places. So what does that mean? There's a 3.2% chance that your buyer, our 14 people, 8 of them will prefer blue. Now understand, they are individually independent because you have 14 buyers, you have no idea who they are, you have no idea what the background information is. So you can only go by the population. The population is 40% prefer blue. That is the rule set in stone before they come in. So therefore, their preference for blue are all the same. So there you go. That's the answer to number 9. Now, for number 10, you have to think about this. A quality control inspector drew a sample of 20 light bulbs. So usually what I do is I go ahead and write, because I know this is going to be a binomial, right? Because I can't look ahead of, I got ahead, right, all the time. So the total number of trials, in our case, is N equals 20. Now, the next one is if the number of defective light bulbs is 1 or more, then this thing fails. So I'm going to do this. I'm going to write success rate, right, P, and I'm just going to kind of look over this for now and just go to the success rate. I know it's 20%, so 0.2, right? The success rate. I know this is the defective rate, right? In this case, we're basically saying if a light bulb is defective, that's a success. I know that doesn't really make any sense, but you can say that's a defective rate, right? You just got to think about 20%. You want to know how likely it is to actually get to that event, right? In this case, it's being defective. Now, being defective. So now let's go to the next one, which is let me see if I can bring them together. So the next one would be, look at this, the number of success, right? The number of success that we want, in our case, the probability. You want 1 or more. 1 or more. What does that mean? One or more means x is bigger than or equal to 1. Let me use this. Px bigger than or equal to 1. I know it's a little bit crazy here, like that. X is bigger than or equal to 1. So you know what? So for this, for the formula, right, for this thing, you can look at this for references. So you might want to use this. I'm gonna send you guys a copy of this right here. So basically, if you want binomial probability of less than or equal to a particular number success, right, or less than or equal to, means at most, right? That is binomial CDF NPX. So this one is not too bad, right? Basically, CDF tells you every probability from 0 all the way to that particular number that you want. So if you want 4, it will be 0, 1, 2, 3, and 4. Now, if I want the probability of less than X success, so if I want less than 4, you have to go up to 3, right? Think about this, right? You cannot be 4, right? If we want less than 4, then you have to stop. You have to stop at 3. So look at this. That's why I have to do minus 1. So let's say this is 4. 4 minus 1 is 3. Binomial probability of more than or equal to X successes, or at least, right? That's when you have to think about this right here. The 1 minus. I know it doesn't make a lot of sense right now. Well, here. Let's say we have 10 numbers, right? Let's say we have 10 students, or 10, 10 students. We want to know what's the probability that, let's just say, more than or equal to 4 will pass this class, right? Successes. Well, more than or equal is 4, meaning you go from 4 to 10. Right, the one that I bolted it out, right? 4 to 10. So from 4 to 10 is what I want. The problem is binomial CDF tells you the left-hand side, not the right-hand side. So here's what you got to do. I will take 1. 1 is 100%, right? This is 100%. The whole thing. Subtract. You don't want this part. This is the part that we want to eliminate. This part, right? The part that you want to eliminate between the bracket, 0 to 3. Well, how do you do it? It's binomial MP3, right? So therefore, you have to do 1 minus binomial CDF MP, not 4, but you have to take 1 away from 4 to get to 3 in order to produce this. Now look at the last one here. Binomial probability of more than X success is 1 minus binomial CDF MPX. Well, this one is exactly what you think it would be. 100%, right? 0 to 10, that's 100%. Probability of more than 4. Well, more than 4 would be 5, 6, all the way to 10, right? So which part do you not want? I don't want 0 to 4. But how do you find the probability of those guys? That's MP4, right? That's the regular binomial CDF. So let me copy this here so you can see it. So we have a few different, make some spacing. So we have a few different code here. You gotta think about this, right? So we have also binomial probability of exactly X successes. Binomial PDF NPX. And then the last one we had was this guy. This. So let me see if I can put them together. There you go. I don't like this. So let me say or eco. So then just like that. So this makes it a little bit easier for you when you do your homework. So use this. Okay. These are the code that you want to use. to get the binomial going. So any problem that you see, just use that. And as you practice, you will see. It's once you have this, it's actually not too bad. So just when you do your homework, when you do your test, just make sure you have it with you. I'll send you guys a copy of this. So if you go to the problem that we did just now, right? This guy right here. So we have x bigger than or equal to 1. What does that mean? This is the same thing as more than or equal 1, right? So then I just scroll down, and you can have the cheese. You can have this table, sit somewhere when you do your homework. More than or equal. That's this guy. So there'll be 1 minus binomial CDF NP x minus 1. So in our case, would be binomial CDF. There will be 20, right? That's the n, p is 0.2. And the x is going to be, let me see, 1 minus, right? And this would be more than or equal, right? More than or equal is x minus 1. So I would not put 1 in here. I'll do 1 minus 1, which in our case would be 0. So now let's put this in the calculator. So that would be 1 minus stat. My bad. Second file, right? That's how you get the binomial CDF right here. Binomial CDF. And then 20, 0.2, and then 0, like that. So I get 0.9885, and that's 4 digits, right? 4 decimal places. So this is the answer right here. Well, let's do another example, right? Because this stuff is hard. This one is, the math is not hard, it's just, you have to think about how to use the actual code that we have here. Let me see. I'm going to try to use this as well for the next problem. So now, let me delete some of this. So a real estate agent has 18 properties that she shows. So I know right from the start, n equals 18. Right? N equals 18. Then I have, she feels that there's a 50% chance of selling any one of them during a week. So I will say P equals 0.5. Right? So we already got success rate. The chance of selling any one property is independent of selling another property. So, let's just say that's true, right? They're independent, and they need to say that. Otherwise, it cannot be binomial. Compute the probability of selling no more than 4. So now, x is no more than 4. Right? No more than 4. Well, what does no more than 4 means? No more than 4 means 4 or less, right? So you can say this less than or equal 4. Well, we know how to do this because based on, so again, I go back up here, right? Less than or equal to 4. That's this guy. That's at most, right? No more than 4, right? So there'll be binomial CDF and PX. So this one's actually an easy one. Binomial CDF 18, 0.5, 4. That's that. So let's put this in the calculator. So again, second var, and then you scroll down to binomial CDF, and then 18, comma, 0.5, 4. And I have 0.0154, and that's 4 decimal places. So about 1.5% chance you will sell no. So for number 12, determine the number whether or not the given procedure result in a binomial distribution. Right. So basically, give you a question, an experiment, and you just want to see if it's a binomial. It has to meet those three credentials, right? Survey 36 people to determine which brand of candy bar is their favorite. This is an easy no. Why is it easy no? Because we are not asking whether or not they like candy bar, which is a pass or fail, success or failure, right? We are asking which brand is their favorite. You can have multiple choices, right? You can have Hershey, you can have, man, I don't know, Kit Kat or whatever. There's a whole bunch of different candy bars around, right? So answer is no. Why is it no? Because there are more than two outcomes for those guys. There you go. Assume the random variable x has a binomial distribution with the given probability of obtaining a success. Find the probability. So basically, this is easier. This is a binomial. This is exactly x equals 4. So this would be binomial, right? Binomial PDF, right? Remember exactly is PDF, right? And there will be 6, 0.3, 4. Right. I'll put that in calculator and you should get it. Right? So remember, PDF means exactly. Over here is less than or equal to. So this guy is less, so x is less than or equal. Less than or equal to 3. So then you can go back to that cheat sheet that we got. Maybe just print it out and see, right? Less than or equal to is this guy. So the CDF. So binomial CDF, right? And there'll be 7, 0.4, 3. Done. Now this one's less than. Right? This guy x is less than 5. So again, we gotta look at what would that be, right? If it's less than 5. So less than a number right here, less than, just less than, right? Is NP, then you gotta subtract 1. So it'll be this. So it'll be 9, and then 0.7, and 5 minus 1, basically. 5 minus 1, which is 4, right? 4, just like that. And for this one, it's bigger than 3. So bigger than 3, that's more than 3. So more than x successes. That'll be this right here. So that'll be 1 minus binomial. It gets a little boring after a while, but that's a good thing. That means you understand. 4, 0.7. And then if you go back and look, right, more than has no minus 1 here. It's just x. So in our case, will be just 3. And then just put those in the calculator and you'll get the answer. And that's the end of binomial. It is a little bit tricky. The math, the imputation is not difficult. The concept is what you got to think about. But repeat those for your problem and you should be fine.